Hello everyone, nice to see you all once again in this new video lecture. I am Dr. Smita Pimple from Progressive Education Society's Modern College of Pharmacy, Nigdi, Pune. Today we are going to study about the solid state, which is a very important state as far as the pharmaceutical formulations are concerned. So let us study about solid state. Solid, they are basically characterized by certain inherent properties like rigidity, mechanical strength. Solids have enormous mechanical strength. Then incompressibility due to close packing of constituent particles of matter like atoms, molecules or ions. Solids are highly incompressible materials. They have definite mass, volume and shape. Because this happens because of very short intermolecular distances and strong intermolecular forces of attraction, which we have studied previously in intermolecular forces of attraction. The constituent particles, they remain fixed at their positions and they can only oscillate about their mean positions, means they are not free to move. Like we can see that in liquids or in gaseous, the molecules are comparatively very free for the movement, and in gaseous state the molecules are in continuous random motion, and solids, they do possess very high density. Then basically the types of solids can be classified depending on their structures into two categories, that is crystalline and amorphous. So crystalline solids, these are nothing but the liquids when cooled and eventually freeze to form the crystalline solids. Here the atoms, ions or molecules are arranged in a definite repeating pattern. Molecules, they are arranged in an orderly pattern. You have a particular 3D array in the crystalline solids, whereas in amorphous solids they are also called as non-crystalline solids. So they lack particular ordered internal structure, which we can see in case of crystals, and thus the amorphous solids are randomly arranged molecules or particles or atoms. So this is the basic difference between crystalline and amorphous solids. Now to understand the properties of crystalline solids, we need to learn certain definitions. So students, just have a look at these definitions. Crystal lattice, it is orderly internal arrangement of particles, may it be atom, molecule or ion, in three-dimensional space. Unit cell, it is the simplest basic unit or building block of crystal lattice. Crystal habit, the external shape of the crystal. So when the crystal lattices join together, they give the crystal certain external shape. It is referred as habit. Crystal faces, the plane surfaces of crystal lattice. Interfacial angle, the angles between the adjacent faces in the crystal lattice structure, and they are same for a given crystalline substance. Now two more properties which we need to understand is isotropy and anisotropy. Isotropy is exhibiting same value of any property irrespective of direction of measurement. The material is said to be isotropic if you measure certain physical property in different directions but it is giving you the same value, then the material is said to be isotropic. So example, like materials, usually amorphous materials exhibit same refractive index, thermal and electrical conductivity. So they are isotropic in nature. And anisotropy, it is when the magnitude of physical property varies with the direction of measurement. So the materials which exhibit different values, if you change the direction for measurement, then they are referred as anisotropic. Example, like you may have different value of hardness if you measure in different directions, or like thermal and electrical conductivity. To understand these two properties, just pay attention to this figure, okay, where for example this is a crystalline structure where you can see the arrangement of the molecules or the particles, we can say. And if you measure certain property in direction AB, so to understand these particles or these molecules are represented by red dots and blue dots. So if you have the measurement along the path AB, then you are encountering only with the blue dots, okay. But if you measure along with this direction CD, then what you are getting is alternate arrangement of red blue dots. So this way you get the difference in the properties of measurement, so that is referred as anisotropy. So this we need to know before we proceed. So we have seen some basic definitions along with this phenomena isotropy and anisotropy. Now in next video we will be studying about the crystallization process in detail, the crystal lattice structures and the polymorphism. Thank you students for listening to this video. Bye for now.